Right, very diverse group, which is nice. Just so you guys know, I actually a lot of times I encounter some of the best programmers in the space. Their background is actually not computer science per se, and they will be coming from a very different part of the world. Like for example, even engineering, mechanical engineering as well. A lot of them are artists as well. Maybe I can introduce myself. My name is Caleb. I'm with ETHKL right now. I do funky things. I do some contract stuff. I write some of the backend stuff as well. Occasionally, I do try to hack some contracts, but that's not for profit. It's mostly for fun. Things like that. For smart contract, I'll try to guide you guys through some of the more entry-level stuff. Let's try to see where we can get with that. And after that, we can see if anybody has any more in-depth question, then you guys can ask. Then from there, we can see how to move on. That could be a subsequent session, I'm not sure, where we delve into more in-depth details or quirks of the EVM, for example. So is everyone in here already? 1, 2, 3, 4, 5, 6, 7.
I think we have enough to start now. And I just asked for the others who haven't introduced themselves, just do it via chat so that Caleb, you can start already.
Mm-hmm. I think it's Harry and R who hasn't introduced themselves yet. Yeah.
Oh, and there's one more, Jerome, who is, I think, not in Malaysia.
Cool.
Yeah. So can you guys introduce yourselves as well, just to like help Caleb like curate the class better? Via chat is fine.
Hey, Harry.
I should specify maybe like some of your programming background. I think in the meantime, Caleb, just
start. Right. So this is how I usually start. What I would recommend for people to start using is to just to start with using Remix. But before we start into that, today what we'll be doing is we'll try to deploy a few contracts through one of the Ethereum testnets, Rinkerby, and from there we'll start interacting with those contracts to see how does it look and feel like. Some of the things which I'll bring you through as well is some of the specifics to blockchain, things like events, why we use events, things like how storage is being managed, how do we call certain things on the blockchain and stuff like that. Everything will be based on solidity. And I won't touch any details on libraries for now. So you would be able to see, even dev tooling, I won't touch it for now. So you'll be able to see how it works under the hood. Once you guys are used to, say, deploying contracts through Remix, then you can start looking into integrating certain development tools, for example, Truffle or Hardhat into your development schedule. That could even involve things like OpenZeppelin and Ganesh, but that's for later, for much later. For now, can you guys do me a favor? Do you already have an address on Ethereum? If you do, can you paste me your address on the chat box? I will drop you guys some Rinkerby ETH so you guys can start off. Or if you know how to get it from a faucet, you can go ahead and take it as well. But otherwise, if you don't have any Rinkerby ETH, just drop your address.
I actually asked all of them to send Rinkerby ETH, so they should have a little bit at least.
Right, everybody got If don't have, just ping me up. I got quite a bit, so I can just distribute to you guys. Otherwise, if everybody already has it, I'm just going to jump straight. Right, screen sharing. I won't be able to see your chat box, so let's go here. Yeah, so if you guys can go, just connect to remix.ethereum.org. One of the first things you need to do is to load the Solidity plugin right here. So you would be able to get this panel. If you guys have anything which is stopping you guys, just raise your hands up anytime at all. right? You would be able to see some of the readily made contracts, but let's discard them for now. So for solidity, usually we would start with something right here. Pragma solidity, this indicates the version of solidity which you'll be using. So if you can see, there's quite a bunch right here. Different solidity versions would have different features. The later ones will have better abstraction, for example, more bug fixes. Some of the earlier ones would have less restrictive controls. I personally quite like to use version 4 and version 5 still, but I should start making version 6, 7 more of a day-to-day build. But anyhow, so yeah, to start programming in Solidity, basically what you have to do is first to define the pragma solidity. This basically what this tells the compiler is that I wouldn't be able to compile this contract using any versions from version 6 onwards. So if, for example, I use version 6.12, that will compile as well. So basically anything from version 6 onwards. Not major versions. So for example, if I switch to version 7, it will start complaining. So we would first define a contract. That's basically a contract name. And here I would just start with a very simple example where we would store a string. So this becomes our variable. And if we have a string, we would then need to define how do we set the string as well as how do we get the data from the string. There are things we can do right here. So if we define a string to be as such, it's actually, in longhand, it's actually private. But of course, if we do it as public, there'll be a slight difference where you can directly access you'll create getters, you'll create getters for the variable where you will be able to access it even if you don't explicitly create a function to call it. But anyhow, let's move on to setting the function. Store something. So right here, we want to store something into the string. Let's see, I have a string. Here we would get an error by right. Yeah. So this is one of the things which they introduced in later versions of Solidity to make it more explicit for people who are coding on it. In older versions, you don't need to specify it. In newer versions, for certain data types, you need to specify this. So what it basically means is that for certain data types, you can think of them as things like objects, where you would reference to them using a pointer. You want to specify that it's a memory. It's more of a syntax thing. So so basically what you just need to remember for structs, for string types, for byte types, if you omit this, you would see this, you basically see this sort of complaint when you try to compile the contract. So just remember, you should put in a memory right there. So this effectively stores something onto this particular variable. And to get it, since we have not defined a getter for this particular variable, you would want to do it as a public view returns, as well as this being a string. So what's that right here? It's the same thing. So since we're setting a pointer, so we should do this. I'm just gonna steal something from right here. It's a warning, so technically we can sort of like ignore that, right? Let's see. Yeah, we can ignore the warning. So have everyone gotten this far yet?
Which one?
For example, have you managed to type in all this code into your ID?
Yep, managed to get it.
Yep.
If you compile it, do you at most just see a warning, for example? This one I'll explain in a bit what this means, but if you are just coding for fun right now, you don't really need to bother with it. But so far, any questions? I think it's quite straightforward. It's basically you're storing a variable, you're getting the variable. Yep, you guys all good? I'm gonna move on. Right, so in Remix, there's this nice thing called the JavaScript VM. It's a duplicate of the EVM. It's embedded into the Remix IDE as it's something like the EVM, but it's just implemented in JavaScript and it runs natively. You are given some amount of if to start with. All the interactions can be done through the console right here. So if, for example, right here, if you were to click deploy, it's not deployed onto the blockchain, but it's just deployed as a test right here. So you would be able to already start interacting with the contract. So if you click on get something, since we have not assigned anything to begin with, we would not see anything. But however, if we were to type in something, you have a string, you would see there is a transaction which has been done right here. There will be a hash and everything. You can see the input data. It's a bit less clear right here, but I will show you through ETHKL how would it look like. So at this point of time, if you were to retrieve the string, then you would be able to see what's the data underlying. Right, is it clear so far? I am open to any questions from here, because from here we'll move on to actually deploying on Linkabit.
Caleb, Nicholas asked, what's the difference between all three environments?
Okay, so JavaScript VM, it's a native VM within the Remix IDE itself. It's something like a test, something like Ganesh is basically a test environment. Injected Web3, it's what you have inject right here. So Metamask, I have injected Linkabit test network. So that's where it will connect to. I'll show you in a bit how do you connect to it and how do you start deploying on EtherScan. Web3 provider, it connects to an endpoint. So you can define it as a local node, which you are currently hosting yourself. You can use Infura otherwise, for example. It's basically your own hosted node. So what happens is Remix will connect to your own local host. You can deploy contracts using your own nodes. Alternatively, you could also connect Metamask through your own node by adding your own RPC endpoint as well. But that's basically the difference of all three of them. Any other questions?
I don't believe so.
Okay, cool. I mean, if anyone else has questions, I'm not sure if you guys are allowed to unmute yourself. I can just pop by and ask. Right, so this is quite boring to look at. So
I just allowed people to unmute. I didn't realize that was on. So you should be able to unmute yourself anytime.
So just unmute yourself, just stop me or something like that, or just ask me whatever you want to ask. Right, so let's try deploying this actually on Linkabit. Hi, Harry. So for Metamask, what's the underscore O? Oh, you mean underscore A, is it? This one?
Variable.
It's an input variable. So right here, what we are defining is that store something is a function. We can pass in a variable so that it would eventually be stored into, I have a string. So this one is something like just a definer for an argument for us to pass in. Cool. Right. So Metamask, make sure you have it pointed to, got it, Rinkaby right here. So if I'm doing this correctly, if I click on deploy, it should pop Metamask. So I hope most of us, we know what all these things are. Gas price. Yeah, gas price have been expensive recently. Gas limit. Yes. Gas limit. You guys know what gas limit is? Right? Then, I mean, oh, before that, let me go through one thing which I think is important to share. Optimization. It's not so much important right now if you're starting to learn, but eventually when you start building more things on it, then you start realizing there's actually a lot of restrictions when you build on blockchains. Each contract address is allowed to have up to 24 KB worth of bytecode. Now that's not a lot. So if like say you are just about roughly over 24 KB, you can try optimization. Optimization will help you reduce some size of your bytecode. However, it doesn't mean that the higher number, the higher the optimization count. The number right here, what it means is that how many times you expect people to interact with your contract. So if it's like, for example, a one-time deployment and you don't expect a lot of people to ping your contract all the time, you can set it to 0. If I'm not mistaken, 0 is actually much smaller. The more times it is, then you can set for higher number of times. So if you see things like, if I'm not mistaken, Uniswap has quite a high number of optimization count. So what that does is basically tells the contract that I should optimize it. So whenever people call the contract, it should be cheaper for people to call the contract instead of me deploying. My deployment will be bigger, but it will be cheaper for people to interact with it. So just keep in mind, you can set it to defaults for now, but eventually when you start developing more complex contracts, you'll come into problems with the bytecode being too big. During that time, you can experiment around using optimization, or you can start using things like libraries and stuff like that. But anyhow, let's move on. Let's deploy this on Rinkaby. There we go. So what we would want to do is to verify and publish it so we can get that nice little feature where we can interact with the contract directly on EtherScan. So single file, the difference between them three, as long as you are developing on the root of development, you'll realize that there are a few ways where the compiler will be able to read files. Right now, the easiest way is of course to code everything in, for example, a notepad or something, and everything gets a single page. But you could also deploy it on multiple pages. You can code in multiple pages, and after that, you can do something like you can import certain files into your contract and do stuff like that. I won't go there yet, but if you start experimenting with more dev tooling, they will start abstracting a lot of those things from you, but they will tell you also you need to import certain files in order to tap into certain features. But for now, we are fine with using single file. We have to select the version we are using. So as earlier on Remix, let's see what you were compiling it with. Version 6.12. Open source license. Any open source developers here? So if there are open source developers, then I think you might be quite familiar with some of the licenses right here. Yeah, for example, MIT is a very permissive license. Some of it's more copyleft, stuff like that. This one has nothing to do with the verification process by itself, but it's more towards on EtherScan whether you can do certain filtering, or from a legal perspective whether you can copy certain bunch of the codes and stuff like that before you get into trouble.
Caleb.
Yes.
If I accidentally rejected the deployment on my wallet, do I need to do anything? Because when I try to deploy, it says the transaction failed afterwards.
Oh, okay. If you do see that, try to go to your transaction and see what's the problem. Is it an out of gas problem, or is it because, but when you compile, you can compile the code, right?
Yes, I believe so. Yep.
So if you can compile the code, double check to see if you're sending enough gas. Maybe you can share your, oh, this is great. You can share your transaction hash right here. Let's take a look to see what's the issue.
I can post it in the chat.
Should close Skype. Where is my Skype?
I don't think I have the transaction hash again. I'm currently stuck right here. Wait.
It's all right. If you don't have it, okay, let's see. That code looks all right. So
compile it first, right?
That looks all right. If you try to deploy, let's try deploying. Oh, injected Web3. I'm not seeing a Web3 on the drop down, so you might want to. Can you try refreshing the page? See?
Okay. Yeah, because when I clicked deploy the first time, there was a pop-up for my Metamask, but then I rejected it, and then I tried again, but then it just didn't pop up again. So do you need to compile again?
Yep. Yep, that's the right one. Oh, can you go to Metamask? Take a quick look.
Oh, there you go.
Ah, okay.
All right.
Oh, you have to give it permission to access.
Okay, cool. All right.
Okay, there you go. Try to deploy and see.
I think I have deployed it, right?
Oh, okay, cool.
All right.
Okay.
Thanks.
Sure. Let's go back. Yep. So these are some of the things which you'll see. Like if, for example, your transaction gets, if you can't prompt Metamask for some reason, you have to see whether Metamask is properly connected and injecting Web3. Other things like, for example, if your transaction runs out of gas, then you would need to bump up your gas. Sometimes it's just weird that gas estimation is wrong, but who knows what's actually happening in the background. Yeah, if you see that's wrong, then you need to start doing some troubleshooting. Let's see. Right. So I am here. Simple. Runs is the same. So, nope, I'm not a robot, but there are no bicycles right here. Traffic light. Ah, let me through. Verify and publish.
One question there, what does the verify actually do?
Right, has everybody managed to get to this step so far? Or did my verification help also verify your contracts? Because EtherScan has this feature where if there is contracts which are similar, which is an exact match with one another, then you would see it being verified as well.
So as long as I see my transaction is done in Rinkaby in EtherScan, means it's done, right?
Yeah, it's deployed. So if you see something like this, maybe I can describe a bit the transaction right here. What you should see is it would say this contract is being created. There's a bunch of weird bytecodes right here. If you see something of this nature, it means it is creating a contract. If you click on it, you should see it go into a link where it's displaying a contract address. You'll see a contract tab right here. I'm pausing for like 30 seconds. So if anybody has any issues or questions, can ask.
So I have a question. So this verify and publish contract source code, is it something that necessary to be done?
Okay, so the interesting thing is this. It's not necessary to be done per se. You can leave it. Say, for example, if you're not doing it, this is how the contract would look like. I'm sure I have an example which I did not verify in the past. Yeah, there you go. It will look like this, bunch of gibberish. Well, if we are developing something for the open community, typically we would want to verify it. So others from the community would be able to see what the code is actually doing, because bytecodes is not exactly the most intuitive to read. It's optional. Of course, for example, if you claim to have some proprietary code which you don't really want to open to the world, you can leave it as bytecode. That's perfectly fine as well. But otherwise, if you're developing for the open community, then the suggestion is always to publish and verify your code somewhere at the very least, in a way where people can reproduce it, can read it and see and understand what's happening in the background. I mean, at worst, what you can do is you can publish it in GitHub and tell people, yeah, this is the link. People can read it up. They can try to recreate the bytecodes themselves. But otherwise, it's definitely a much better practice to publish and verify on EtherScan.
And so my follow-up question would be, if I need to copy and paste my code into this verification, should I put comments as well, saying what each function is doing, each line?
You could do that. Yeah, putting comments is always nice, so that you can remind yourself what the contract is actually doing. Yeah, you can do that. Comments, basically, you can do it as a block comment like this, or you can do it like double backslash. Yeah, you can do that.
So here in this case, it also includes the actual source code, or is it like a decompiled version?
So this would be an actual source code. If you want to, if it's decompiled, it will look quite different, because if it's decompiled, usually we'll decompile it back to a certain sort of like stackish language. It would not be one-to-one with the solidity language which you're putting in, because when it's translated to EVM bytecodes, it's fairly different. I would say it's more like you're dealing with a bunch of memory, then you're specifying what would you be doing with this bunch of memories. Interestingly, let's see if this still works.
I tried putting API thing in the verify publish contract source code. It says error.
Oh, all right. Could you show your screen?
Okay.
Try again, Rafiq.
Yeah. Let me open up that. Invalid constructor argument.
Okay. So right here, I will get to constructor arguments in a bit, but if you go down to your constructor arguments, you should remove this. Actually, yeah, I can see why you put it in. ABI encoded. It actually means something else, but for now, your contract don't have ABI. It doesn't have that constructor arguments yet, so you can remove that. So basically, the constructor arguments, you can remove it. I will explain a bit what constructor arguments are. Yeah, I will show it to you guys. So just clear off the constructor arguments, the view.
Hello. Yeah. Sorry.
No, you disconnected. No worries. Yeah, you should clear off the constructor arguments view. I'll explain in a bit what that view does. Later, I will show you guys how to deploy contracts with predefined values. That means during deploy time, you can set certain arguments. That's what we call constructor arguments. During that time, you'll need to use it. But typically, EtherScan would be able to approximate for most cases. But if you need to, then you can put in the values yourself as well. But the constructor argument for this case should be empty. Yeah, so to answer your rune earlier, if it comes to interpreting the bytecode themselves, it's actually much lower level. So it looks really weird actually. It's more of interpreting the stack, the memory, the operations done on the stack and stuff like that. So solidity is actually considered fairly abstract really. But that's the best we can get to if we were to decompile the bytecodes. That's why it's always recommended that just publish the solidity code so people can actually understand on a higher level what's happening right there. Right, shall I move on?
Okay, cool.
So once you have this on EtherScan, pretty much you can start interacting with the contract as well. Of course, get something will be empty because we did not write anything to it. So if I write something, there we go. So during this time, we would be able to likewise read the variable. Let me try something. Yep. Okay. Now, I'm grinning to myself about this because I did some changes for this, which I forgotten myself. But anyhow, I did some code changes for the right contract page right here. But anyhow, this is how you can see it. So what you have effectively done is that you have deployed a contract on Brinkerbeat testnet. You can actually simulate the same steps on LiveNet, mainnet. It's basically a matter of just changing the drop-down right here. Changing it to mainnet, and it will actually cost you money. How much it depends on the network gas price at the moment. Probably for something like this, it's probably like 20, 30 bucks US dollar. Yeah, if I'm not mistaken, whereabouts. You can interact with the contract. You don't necessarily need to develop your own DApp. You could develop your own DApp. But usually people use this as a fast way to test their contracts, to be as a fallback for the community to be able to interact with the contract in case of their own website going down. And you basically get the full suite of everything. You can read, you can write, you can investigate and see what's the code up to. Yep, so has everyone managed to get this far so far?
Yeah.
Yep.
If you have managed to get yourself so far, this far right now, I would like to congratulate everyone because you have technically successfully deployed a contract on Ethereum. Basically, that's it. That's why developing on Ethereum is nice in a sense. You don't need to overcomplicate yourself with setting up and stuff like that. Just go on Remix, start typing out code, then you just deploy it. It's more of you can already do something with it right today. So what we are doing right here, it's a very simple example, but imagine if you can expand it and start doing more things. For example, you start storing more variables, or you can specify a web page where if certain variables are set, it would display something, for example. So that's where it's from there onwards where you can start getting creative and start building quite a lot of things on Ethereum. But before we move to that, this one it's extremely basic. And in fact, if you have done any form of programming before, this is very basic stuff. You have variables, you have functions, you have argument parameters and stuff like that. There are a lot more things which are very quirk or very niche related to Ethereum itself. One of the examples, yeah, it's called events. I'm not sure if you guys have seen events before. For example, if you were to transfer ERC20 tokens, if you were to transfer ERC20 tokens, if you were to look at its code, essentially it's decrementing from one side and incrementing on the other side. So it's minus on one side, plus on the other side, and that's it. But then again, you would be able to see certain things happening on it. So for example, on the logs, you'll be able to see the transfer event and stuff like that. Yeah, Shoha, go ahead.
Caleb, I have a question. So just now I write the contract. So the first time I type in if I write something. And then I can see when I read the contract that get something, that message. So the next time I write another contract, if I write something too, right? So the latest get something is if I write something too. Is it possible for me to know the previous get something?
Good question. There are ways to do it. The most efficient way is what I'm going to introduce in 15 seconds. So I was touching on events earlier. So for example, if you have something happening in the past, how would you be able to find out about it? In blockchain terms, it's actually not easy. It's only easy because EtherScan does everything for you. But if, for example, you want to do something like you want to know from a single address perspective, what are all the transactions which have been sent by this address? What on the backend you actually need to do is to index every single block from Genesis, read to see whether this address has sent any transaction in this block, and you store it to a database somewhere. That's how complicated it gets. And imagine if you have like a million blocks to go through, you have to look through them each one by one, you have to parse through the data, you have to look it up and search for that particular address, then you store it into a database. It would take hours and hours of indexing time. That's what we usually call it. So when it comes to wanting to find something which has happened in the past very efficiently, we typically do it in contract terms. We typically do it in terms of events. So how does an event look like? So for example, earlier Shuha, I mentioned that if, for example, I have write something to, how we know that there is an earlier information which we have entered. Using events, you will be able to parse it quite quickly. But it will come more to a time where if you are doing things like displaying certain data, or if you are doing some sort of search engine through the blockchain to parse certain data, it's more relevant to you. But if you are coming from a perspective of an end user, what you could do is to, for example, look through certain events which had happened in the past. So I don't think I have a good example right here, but if you look at the token, of course I don't have a token right here. So essentially what all the transactions which are happening, if you go from the perspective of an account, you see all the transfers is essentially some sort of event which is being emitted onto the blockchain. So if you look at ERC20 tokens, these are essentially all events. So you can see past transfers or what are the past things which has been done. If you need to look up for specific data, then you need to customize things a bit. ERC20 is defined as a standard, so it's easy to retrieve data. But if, for example, if you need to look for certain things, you will need to customize a certain event. You need to filter it. It's a lot more efficient to retrieve because events, they use a certain primitive called Bloom filters. You can go through the blocks a lot more fast than having to pass each block individually manually. So how for the purpose of this, I'll just start with showing you guys how to code an event first. Say, for example, change string something. like that. So what we have done here is that we have specified something like a variable. We have specified that an event will be emitted. Not even there yet. We have specified that there is an event which we can emit changed every time where we have stored something right here. Right, so if I were to deploy, and if I were to go through the same steps,
So when this happens, are we rewriting a new contract?
yes, you are writing a new contract. If we have time later, I might introduce you guys on ways of how to use upgradable contracts, but that one is a lot more technical. So let me go through the primitives of what we have right here first. So you know how to deploy a contract. Second step is if you want to index certain information, if you want to present certain information from these contracts, you can use events to show that certain events are triggered, certain changes are done. So let's do the first one. Let's see how this looks like. This is number one. So if you have an event in your contract, we'll be able to see this under the transaction. If you look at logs, you would be able to see what that particular transaction has done. So it's a more explicit way of telling people that certain change had taken action. It's also a more explicit and it's a more efficient way for developers to be able to retrieve from the blockchain what exactly has happened, especially when you start developing more complex applications, when you need to retrieve data. Events will be able to help you quite a bit. So this is number one. So what happens if I update this?
Okay, while we're waiting, Harry asked if we can build an ERC20 contract.
We could, but even ERC20 contracts, okay, so the thing is I typically like to start with something a lot simpler. So but I understand where you're coming from, Harry, because your background, yeah, you are a developer, so it's much easier for you to catch up. Yeah, but it's typically something which I like to do, come out from small chunks. And after that, you start working on more complex examples, especially, for example, ERC20 contracts. I would need to start explaining things about like what is the EIP20, what are the standards defined, the reason why we use return Boolean in the end of the transfer, stuff like that. We can set up another session to work on going through some of the more complex details as well, especially from a ERC20 perspective. But I guess not now. We can start with something more basic. We can work up something more complicated eventually. But it's a good suggestion. I probably should come up with some course materials which surrounds tokens instead. That could probably help quite a bit.
Hi, Caleb.
Yeah.
I was just suggesting, like, but because ERC20 maybe will cover little bit of the common details and maybe little bit of the what actually the token is, the smart contract actually can do. That's why I just suggested. It's up to you whether you want to.
It's a nice suggestion. I should probably
explain both the small detail and more complex detail so that everybody know what actually smart contract can do. What actually.
Cool.
That's why I just said a suggestion.
You have done smart contract stuff before, haven't you?
I done, but it's just sometimes you're out of touch, then you just want to know.
Right. Cool. I mean, on the subsequent classes, maybe I can see you again. We can discuss further on how to structure the some of the courses as well.
Okay.
Sure. Thanks. Right. So for events, the second transaction right here. So if you compare the log from one side to the other side, you will be able to see basically each transaction, how does it affect the state of the contract. So that's where it comes in. If you want to know at which point each transaction when interacting with the contract does certain changes, you will be able to see what has been done. From a parsing perspective, it's a lot more efficient as well. You don't need to look through every single block and stuff like that. So are we covered with events so far? Any question?
So most of the time, these events you'll use them when you are watching for new blocks, or is it like something that is directly usable with EtherScan as well, or?
So events are very much used in EtherScan, yes. You would typically raise an event when you want to, for example, index a certain information onto the blockchain. So while the blockchain stores information, which it basically continually appends information onto the database, you would want to trigger certain important points. So for example, you start using events when you want to track changes, explicit changes, which you want to take note of. So for example, for you could be when certain data points have been updated. For example, for other people, it would be emitting certain events to tell people that certain transactions have happened, certain transfers have happened. It depends on the contract which you're building. Events do have a gas cost overhead, so you need to be careful with that as well. But otherwise, it really depends on what you're looking to sort of like throw out there to make it easier for you to know what's actually happening.
Okay, I see. Okay.
Sorry, Caleb. So can I say events is more like a marker for like the points of those that you think is relevant data that you want to retrieve later?
Yep, that's a very good way of putting it.
Okay. Just example, is it something that is like something you see in like owner for an NFT that it keeps changing, and is that how they use events to track that?
Yep. Let me quickly pull up the NFT specs for a bit. So if on an NFT, if I create an event which says owner changed, then yes, you will be able to see that the owner has changed. If I'm not mistaken, there is indeed a specification for this. Yes, owner change, you can emit an event. It makes it much easier. So for example, if you were to pass through the data on the blockchain, you would be able to look for certain things like event. You can specify a filter saying that you want to look for the events starting with the function saying that it's owner changed, for example. So you would be then able to very quickly return the list of owners which have changed throughout the time.
All right, thank you.
Yep, that's right.
Caleb, I got two questions.
Yeah, sure.
Regarding events, are there different kind of events or only one type of event? And the second question, whether it will trigger once or we can trigger any time. Means after we triggered, we want to trigger the same event. How it will work? Can we work?
Okay, cool. Interesting question. Right. Events, basically, there is only I would say, one type of event in the sense where this primitive, the event primitive itself is a type by itself. Within events, there are different ways to do things. The easiest way is just to admit something right here. There is another keyword called index. Index, when you start doing things like filtering through the events, you can specify that there are certain keywords you want to index. For example, if you have done database related work, you would have an index key which makes searching a lot more efficient, and you can filter specifically on certain values as well. That's the different sort of like ways you can use event. As for how many events you want to trigger, you can trigger as many as you like. Typically for developers, for smart contract developers, we will trigger event very typically once in a function, because we want to show people that this function has happened. Sometimes you might trigger it twice, but I very rarely see that. In fact, most of the time is that when you do a sequence of action, you would probably trigger it like 2 times or 3 times, but that's because you are triggering like 10 different functions at one time. So easiest way to say this, let's look at Uniswap. So you can see the list of events right here. There are so many events for this, reason being because Uniswap essentially is actually interacting with multiple different type of contracts at one time. So not just transfer, it has to trigger on the other ERC20 token and approval to be able to allow it to do the transfer. It has to do some sort of sync as well on the, if I'm not mistaken, this should be on the Uniswap contract itself. Yep, it has to sync and update the balance on, because it's using some sort of bonding curve, you have to sync and update the balances on both the reserves. So you can call an event multiple times. I would personally not do it too many times, only at the areas where I need to keep tab of certain things happening. But essentially it's up to the developer. The developer can just add as much as they like.
Caleb, my question was whether I can, I know mostly the event will trigger once, because in the function you are doing a lot of things. Mm-hmm. So trigger once the function you have completed your work. Mm-hmm. So my question was whether what the event is trigger. Mm-hmm. After that we want to check that event somewhere it's stored, or you want to read that event again. Can we read that event again, or this? We just can trigger once only and it can be read once only. That's what. Oh,
you can, yeah, you can read it multiple times. Basically, it's stored in blockchain. So, for example, Web3 event. Yeah. I don't use Web3.js that much, but you can look up when you come to developing the apps already and you're starting to use libraries, you can start looking for event filters. Okay. Mostly use Ethereum.
Filters can use to read event. Okay.
So you can pass it through the transaction receipt itself, or you can set up certain things like Ethereum has something called processing. So you can process the blockchain by itself, and after that you can set certain filters to be able to call it. But essentially you can call it multiple times, it's fine. You can read it as many times as you like because it's stored in blockchain forever.
It's not... is any gas involved in reading the events?
When we read the event, no.
No.
Okay, I'll just give you a straight answer because I'm caveating quite a lot of things at the back of my head. To read the events, no.
Okay, okay, fine.
Yeah, sure.
Okay, my question, when I change the code, right, and then I redeploy the contract, it creates a new contract address. I just want to confirm that basically developer cannot simply change the contract and using the same address. Is that true?
Yes, with asterisk.
Oh, with asterisk. Okay, what is that?
Okay, there is a certain deployment pattern which we use on Ethereum. It's called the upgradable contract. or proxy contracts. So what we can do is that we have one database contract and another contract which is an implementation contract. We typically don't use the term database contract, we use the term proxy contracts. So what happens is that the proxy contract itself would store all the information, whereas the implementation defines what you can do on the proxy contract. So during that time, what you could effectively do is on the proxy contract, you can say, I want to update my implementation. So what users would see, they are still interacting with the same contract, but on the backend, effectively, they are using a different set of implementation, a different set of rules. That's one thing. Another thing, it's a bit more, it's slow down the primitive rules. On the EVM, there's something called create to. Now, what create to does is that it allows you to deploy contracts ahead of time in a way that you know what is the contract address which you will be deploying to. So it's basically a very deterministic way of you deploying contracts. The side effect to this is that you can self-destruct the contract and you can redeploy on top of it. Now, that's not necessarily good in a way, because then if you are deploying contracts using create2, it just means that you can sort of like silently change and rack out the implementation. You can change it to something else entirely. There are ways to get around it. So if you were to interact with a contract on Ethereum, I would say just be careful. Just be aware of how the deployment is done, stuff like that. Very typically, people will just deploy a contract as is. Some teams will prefer to use upgradable contracts because if anything happens, they can upgrade it and they can stop bad things from happening, or they can iteratively improve on it. But in most cases, you should see contracts as they are. Once they are upgraded, you will not be able to change it unless you explicitly use a certain pattern which allows for upgrading.
Is this how governance token works? Because I'm not really sure about governance, right? Because from what I heard, if you, let's say, vote for something and the vote is accepted, then you can change the contract automatically. Is this how you do it?
Okay, so if you ask me, I would do it in two ways. There are basically two ways to do it. One is that I can do the governance in a way such that if the vote passes, I can change from pointing from ABC contract to XYZ contract. That's one way of doing it. Another way to do it is that, like you have mentioned, I can do it so that I would trigger an upgrade on the implementation contract itself. This one is very much team specific. There's no real right or wrong. I have my own thoughts about how to do it. So, but you can definitely use that sort of deployment pattern on governance during voting sessions, or when you're deploying governance tokens or stuff like that.
Awesome. Thanks, Kevin.
Sure. Any other questions? Otherwise, I would move on to constructor arguments. Right, so if no questions, then let's move on using the same code base. So yeah, those of you who might have already noticed it, every time when we deploy a contract, we have to trigger store something to be able to store a certain value right here. But there are certain cases where you can deploy a contract and already predefine what you want to store in it. One of the ways is that you can specify in the contractor, or you can pass it as an argument. So how do we pull out the constructor arguments for this case? You would need to use the constructor keyword. It's always public for constructors. So one of the ways we can do it, we can enter it through a constructor, or we can do something like this. Right, or we can do something like this. So string. Oops. So if we have a constructor right here, what we are basically telling the contract is that during deploy time, specify that we will be able to enter some sort of information as we are deploying this contract within the transaction. So if you can see right here, if you have done this correctly, you will be able to see that we can deploy with a certain bunch of strings right here. So you can see something like I would show you guys in a bit how this actually looks like. This one will be important actually. So if you can see right here, this is what we were looking at earlier. Constructor arguments is a bunch of bytecode which you would append to the bytecode as you are deploying the contract, which essentially this is there you go. It's essentially the string which we have attached together with the deployment time. So if I were to just quickly verify and publish this, one quick note, you would very typically see the constructor arguments to be appended to the bytecode at the back. Right here. This is important because eventually one of the days you will realize that you cannot verify your contract on EtherScan. Very typically it's because the constructor arguments sort of like estimated wrongly. We are not able to very confidently tell you what the constructor arguments are. So you would need to sort of like extract it manually and tell us what the constructor argument is. So in this case, how would they look like? When we read contract, we would already see there's a default string. So since our constructor, we did not define any events whatsoever, there's no events which is attached. But then again, our string would already have a default value right to it. So if we write contract and we start updating it just like before, we would be able to see the read contract changing. The get something would change to something else, for example. So is this straightforward so far? Any questions? If anybody has any problems getting up to this point? Nope. Then I'm going to move on. So to recall, we have went through how to deploy a contract, very basic one. We have went through things like events. We have went through things like constructor argument. Did we go through anything else? We have went through. Okay, so the next thing we should probably touch on is a primitive called mapping. Mapping is interesting.
So Caleb, I have a question to ask. Sometimes I get confused when to use memory in putting the input in the function. When should I use memory and when should I use storage?
Okay, so you would use memory if it's like, for example, for the instance of that particular transaction, it's just there for temporary. So storage, you would actually record it onto the blockchain, whereas memory, you would sort of like just use it for that particular transaction and after that discard it. That's the easiest way to think of it. If you are using it for a function, say for example, for a function as a function argument, very typically you would use memory, because it sort of like doesn't make sense. If you are interacting with a function externally, it doesn't try to retrieve any storage items. Instead, for example, if you are trying to retrieve something from which is being stored on the blockchain, then you should specify it's a storage. So I can probably do an example for this, but not right away, because that would probably, I will start going into structs, for example. Let me think of an example which I can give you later. Just ping me on ETHKL or something. Then I will probably code out an example, then you can see what's about the differences. Yeah, sure.
Just a question on constructor. So my understanding is that you can set something when you deploy the contract, right?
Yeah.
What is the example, real life example that we can use for the constructor?
That's a good question. So for example, I have created templates. In the templates, I don't want to say, for example, like hard code anything. I want to allow people to deploy their own contracts, possibly through a factory contract. So during the time, I would then, instead of trying to embed things in this fashion, I would then put it into a constructor. So when people deploy it, say, for example, there's a factory which they can use to deploy their own ERC20 tokens, I would then allow them to be able to specify in the constructor as part of the input parameters what are the values they want to specify for their own ERC20 tokens. Say, for example, they want different names or different decimal points. They will be able to do it through the construct arguments. So that's one of the ways to use it. If you are building, sorry?
Both ways are fine, right? So is there an advantage of using this instead of what you are writing right now?
Sorry, come again. I missed you for a while.
Okay, so when you use constructor just now, you pass some parameter during the deploy.
Yeah.
And then right now what you are doing is you hard-coded it inside the constructor function. So either way, it's fine. Or is there any advantage one over the other?
Depends on reusability. So if you hard-code it, for example, right here, for the person who is deploying it, I will need to change it right here. I need to change I have a string manually. Whereas, for example, if if you were to build something like this, so if you were to define something like address A equals to new sample, this wouldn't compile because that's not a function. I think it's something like this. Wait. Oh, I need to figure out the syntax.
Should be example one. Should be example one, I think.
Yeah, there you go. Function type simple contract. We do address. I need to try to recall how do I do the syntax for factory already. But essentially the idea is that if you're using a factory, then you will be able to define something like, when you're deploying a factory, you will be able to define something like your own string or even some sort of constructor argument right here. So when people were to deploy the factory, they would be able to specify whatever they want by themselves. Actually, let's do this, solidity factory.
A factory contract is a contract that you use to deploy another contract.
Yes,
is that right?
that's correct.
Okay. I think I get the idea. All right, thanks.
I'm super curious what the, I think I will check that out in a bit. I can't remember the syntax. I thought the syntax was something similar to this.
That's fine.
Yeah, so you are here so far. Anything else you guys want to ask? If not, then I would just move on to mapping. So have you guys heard of arrays? So arrays,
Yep.
I think most of you guys would have heard of arrays. So arrays, basically you can sort of like specify, but it's in a sequence where you can sort of like create a variable, which is where the storage you can expand. The storage you can start appending more values of the same type onto it. Mapping is slightly different. Mapping in a sense, it's more specific to solidity in a sense. So what happens is with mappings, you would be able to specify a key value pair. So if you specify, say, for example, an index, you will be able to retrieve the information for the particular index. I have not exactly seen any other programming languages do this yet. I've seen it on Solidity, so that's why I think it's worth sharing. So we can do something like, to define the mapping, it's something like this. So I would specify an index, say for example, U256 to a string. And I would say value, for example. So of course it's all going to error out because I've just retrieved I've just removed I have a string right here. So this is what you would do. I think the syntax is like this. You would want to say, for example, in this case, since it's a key value pair, we would want to be able to enter whatever we like. So it's 256. Say I would do A instead. So score A equals to underscore B. Change. We would also slightly change this as well. Something. So in this case, since we can start appending, we can start storing a lot more data in a mapping, we would be able to also right here specify what is the information we want to retrieve. So return map value. Did I get everything right? I think so. Well, never know until we deploy, so let's do that. Oh, okay. Sorry, I got a bit curious. So I think I was missing this. What's this? Is it not? Oh, okay, we can try this later. Yeah, I forgot to I forgot to specify that factory is supposed to be an instance of, it's sort of an inheritance. It's supposed to be an instance of example one. We can try this later. So let's do this. So if you look at read and write contract at this point, slightly different. See, get something would specify an index. So write contract, you would be able to specify an index as well as a string. Get something right here, since I think we have defined a default string, so you will be able to see a default string. But if we start updating it, we can choose not to overwrite what's the previous value, or we can assign it, say, for example, each user, you get a different value instead. Essentially, mapping is what is being used under ERC20 tokens. So each person would be able to hold a certain amount, each address essentially will be able to hold a certain amount of value under this particular contract. So for example, since we have already initialized 0, if we check 1, it will be empty. So we will put something right here, a second string, for example. So the cool thing about mapping is that you get a huge amount of space to play with. And cost-wise, it's a lot more efficient than using arrays. The only problem is that it's unstructured. So you would not be able to, for example, sequentially pass through it unless you are indexing it in a way where you know what is the index key. Say, for example, in this case, since we are using 0, 1, 2, 3 to index, so we would be able to pass it in a way where we go from 0, 1, 2, 3. But it's not the case for every time. Say, for example, in the case of implementation of ERC20 tokens, the entry point they would use, instead of uint256, which is basically a numeric value, what they would do is they would use an address instead. So during that time it's unstructured, you wouldn't be able to know who has actually been added to this unstructured data. So unless you specifically know that an address exists, otherwise it will return 0. So back to 1, second string. So mappings are really cool. I would say play around more with them, see what you can do with it. You get a huge amount of space to work with. You can do things like you can map to structs, or you can map to certain mappings as well. So far, you guys managed to understand what mappings are?
Yep. Just a question, Caleb. Can you remap existing values?
Depends on how you want to do it. I don't want to sound dismissive or anything. Actually, depends on how you want to code it. So say, for example, if I don't want to allow people to remap, I would write something here. So store something, I would do require that mapped value. Probably something like it's not equals to something. See, for example, this is a very contrived example. Oh, I cannot do it. I have to probably use some sort of oh, sorry, I'm using this. This should be this. Fine. Yeah, string comparison doesn't work. I have to cast it to a Kajac hash instead. But anyway.
Okay, but meaning it's possible.
Yeah. What you can do is something like you have to make sure that it's not something, or you can identify that if the mapping already has something, then you would not allow people to override it, for example.
Okay.
Or you can even do certain things like there are certain points in the registry where you don't allow people to pump in data as well. That's possible also. So it just depends on your implementation. Yeah, sure.
I just want to know what is real life example you use this for.
Okay, real life example, ERC20 tokens. So quick one. You would typically not use it for a string. You just use it for a string because a lot of us, we are very, very familiar with what strings are. It's easier to explain in a way. Oh, great, nobody verifies their contract. On Rinkaby, scan. So real life example, yes. Balance off. So this is an address, this is a uint. So remember earlier our mapping is, there's always an entry point. So this entry point would be your address with your balance. So this is how you would use mapping. This is basically an address where you allow another address to spend a certain amount. So you can do mappings within mappings. Nonsense, this is basically an address up to what point you have already, say for example, deploy the transaction or something, do certain actions. So this is basically how the real life example would look like. Every time you interact with ERC20 tokens, when you are transferring value in and out, essentially what we are doing is a key pair value. So your address and what the value is. So the value could increment, could decrement. Does that answer your question?
Yeah, got it. Thank you.
Yes, Harry.
Yeah, Caleb, can we iterate all the mappings, or is just one-to-one we need to pass every time index or whatever?
Okay. I would say to iterate through mappings, it's impossible. The easy way to explain it is to say it's impossible. Okay. Because the thing is, mappings you could, say for example, if we were to do it as an address right here, it would be next to impossible to tell what are the addresses which are being stored within this mapping. So mapping, you get a huge amount of space. Say it's 256 bits, 256 bits, which you get to work with. So it's a huge amount of space which you'll be iterating through. You can iterate till the end of time and you won't be able to get every bunch of the data. If you want to be smarter about it, yes, you can do something interesting. So you could define an index key. So that's why, for example, right here, what I'm doing is that I'm defining an uint256 to string. So I could iterate through it up to the point, say, for example, I don't see a string being returned, then I can tell myself, yeah, this is the end of the line.
Yeah, understood. I just wanted to know whether Solidity provided any function where we can iterate all the ones.
Yeah, quick answer, no. Okay. It's just too big. Yeah.
Okay.
All right, so do we still have any questions? I actually want to quickly show you guys factory before we wrap this up. Inside, able to get the syntax correct anyway. So anybody else?
Yeah, maybe one question on the mapping also. You use a uint 256, but can you also use a boolean or something to boolean to string?
Yep, you can. So boolean would be very much the same thing. When you specify true, what is the return value? When you specify false, what's the return value? You could use other data types as well, uint8, for example. So yes, you can. I would, because we had 1.5 hours, I would actually encourage just play around with some of the. It's a very simple example, but the idea is that to get you guys to like start playing around with it because it's so simple, anybody can work on it.
Can we do mapping inside another mapping?
Yes, you can. That's amazing things about mappings. Actually, I have not tried this myself. How far can we map it? That will be a nice thing to play with. So this one, for example, is a mapping of a mapping. So the idea of allowance is that, say, this address, how much allowance are you allowing another address to spend on a certain amount of tokens which you have? So that's a mapping within a mapping. Cool, right?
One more question. I just got curious. When we do mapping inside a mapping, my contract, the when we calculate the price, the gas, right, it will be get higher, right?
Yes.
If you do multiple, so it will be much simpler. You just use one-to-one mapping.
Yes.
Correct, right? Okay. Okay.
Yep, that's right. So the more things you do, the more
nobody really do. It's not a pattern, right? To do mapping inside a mapping, or is a pattern people use?
Depends on your need. If you do need it, then I would just say go ahead and use it. It's by itself, I would say it's extremely efficient since it's one of the lower level primitives. I mean, it's already available in Solidity itself, so it's quite optimized. If you need it, just go ahead and use it.
Okay. Okay.
So comparing mapping and arrays. So you're saying that mapping use less gas in the contract compared to arrays?
So yeah, so the problem with arrays is that as it grows larger, you will end up using more gas. So as you start appending things to it, it would start incrementing. Every interaction you would have with the array, you end up using more gas and stuff like that. Mapping is, but sometimes you just don't have a choice. You have to use arrays. Then yeah, just go ahead and use arrays. Otherwise, if you can use mapping, just go ahead and use mapping.
Can we remove data that we've already put inside the mapping?
You can. It's something like when you have finished spending your tokens, your ERC20 tokens, then essentially it's removing your sort of your data within the mapping. But the interesting thing with mapping is that it's ahead of time. You are already given this amount of storage space. So 256 bits, you get access to the entire registry of storage space. So it's already predefined. If you were to revert it to mean, it's basically just turning it back to zero. So you see your balance being zero, for example, and stuff like that. Whereas the difference with array, the difference with array is that array, you need to like pop off the stack, you need to remove that element, then only you can consider it as it's really being removed. You guys?
Sorry, one question for me. Just, I don't know if you want to mention this now or maybe some other time on hygiene of if people do things on mainnet, how they can like help not bloat the state.
I mean, if you guys want to experiment and you're willing to pay to experiment, then just go ahead, I would say. It is a public good, so nobody can stop anyone from doing something. I would say as much as that, but I mean, yeah, it's expensive to deploy contracts on mainnet right now, so might as well just use Rinkerby. Rinkerby, Robstern, Coven, you can use that. If you want to test in prod, you can do that as well. I do typically test in prod, but I mean, if you want to, you can put a self-destruct and after that can destruct it later, but just keep your test in test nets for now. Right. I know we are above past our time, but you guys want to see a factory example, or should I keep it for late? Should I keep it for next time? There are other things I do have in my list to share as well, things like delegate core. But it's a lot of things which are very specific to Solidity and developing in blockchains. I even skip the part where we are talking about arrays and stuff like that because that's very traditional programming. So you guys have 5 minutes?
I'm fine, Caleb. It's up to you because you are, and Haris is the organizer.
Okay, cool. I would just quickly go through factories since the question has already been asked. So, generate new contract. Public. I need to mark this as an abstract. well, there's always contract should strike. Do I want to do that? Let's see, what am I missing? Do I need to go the whole amount of creating an interface for this? Hope not. So stop. Why not I figure this out later, then I'll share in the group. I'm probably forgetting some syntax stuff. I did not check this out before I started this session. So it's typically some syntax which I'm missing out. Yeah, especially on Solidity version 6, I'm quite sure there are some syntax changes already. On version 5, then I need to downgrade my code, so that wouldn't work as well. Things like constructor wouldn't work, so I'll figure out on the factory part, and I'll probably share with you guys later on the reason why we would use constructor as an input, how we would use constructor arguments for input. So because the thing is the fact that it's when we are using factory contracts, we can then allow people to enter whatever they want. So during that time, you can then, if you start specifying it as an input argument, it would help people to be able to create whatever instance of a contract they like. So they can start defining whatever input parameters they like. Say, for example, if it's an ERC20 token, then you can specify what's the name of the contract, what's the decimals, what's the initializing number, and things like that to balance. But I will work on this. I'll let you guys know. I'm quite sure it's something to do with inheritance, which I've forgotten about. Yeah, sure.
Okay, just now you said something about the smart contract size, 24 kilobit, if I'm not mistaken. Where do we check that, yeah? And my second question is, inside this Remix Studio, there is one thing called publish to ipfs. What is this?
Okay, so the 24 KB part, if you try to deploy something which is more than 24 KB, you will get an error. But even before that, when you try to compile it, the SOC compiler would really complain about it. It will tell you that your contract is more than 24 kilobytes, and if you try to force deploy it, then you would end up things like running out of gas, or it will revert. So even if you want to deploy it, you won't be able to deploy it. Sorry, come again with the second question with Remix ID.
I publish to ipfs. What is that?
Okay, ipfs essentially is a decentralized storage. So if you were to publish to ipfs, what it essentially does is that it will publish the source code to ipfs. So it's basically a way for developers to store their source codes on some sort of decentralized storage, so other people will be able to access it. There are other options, like for example, Swarm as well. So it's just a nifty way for people to be able to store code on ipfs, and after that, when they want to retrieve it later, they can also retrieve it.
But you can also do that on EtherScan, isn't it? I mean, you can view that.
Yeah, but I mean, you get people saying that EtherScan is not decentralized per se, so they would much prefer to keep it on ipfs, stuff like that. It depends on yourself. But I mean, yeah, since EtherScan is a block explorer, having the code right there to be able to look and interact with it would be quite nice also.
We might want to organize a decentralized internet or decentralized storage meetup with someone like ipfs or we in some future meetup.
In fact, you used to be able to like link to ipfs a website, so you can very quickly hack up a HTML website, load it on ipfs. Then, if you're using Metamask, you can load it in browser. Quite nice, actually.
Cool.
So, any other questions? I don't want to keep you guys long. I've figured this out, and I'll share it on the group. But I don't want to keep you guys long.
Caleb, one last question. I just was curious. I was wondering whether can we interact with the deployed contract? Like if it's just like any other ERC token deployed, can I, if I'm writing a new contract, can I talk with that contract and use some function, or it's not possible?
But you are talking about interacting in which sense? Say, for example, like a website or?
No, I just want to interact with other contract.
Oh, okay. You want to interact with other contracts? Yes, that's possible. It's the inheritance part. What you would do is that you would specify.
No, Our inheritance is another, but I just want to interact with the deployed contract already is on the. Like a Rinkerby, we have an address already deployed. Can I directly talk with it, or can I use this function in the contract itself, or?
Yeah, you can go from contract to contract. That's possible. You can also go from interface to contract. Third way of doing it is that you can use a certain function called delegate call. So you can delegate call to an existing contract and use the implementation of the contract to be able to amend your own state. So yes, you can sort of like do some really funky things, like you can bring across 5 contracts, then you have one contract which coordinates on all 5 of them. Yeah, that's possible.
Yeah, because I just like thinking, because people deploy the contract already, so rather than create a new inheritance, just use the existing deployed contract, and it would be more useful.
Then that's a nice way to think about it, because if you're already thinking about that, that's basically 2 things. One is like we are talking about composability of contracts on Ethereum. So for example, we have things like Compound, Aave. We have, like, for example, the entire Yearn ecosystem is basically plugging in very different money Legos, DeFi Legos, so that they can do very different stuff. It's under a single contract. It's essentially composable. So one contract would interact with 5 other contracts, do some crazy things. You can also think about proxy contracts, so contracts which you can upgrade. So essentially, it's actually 2 sets of contracts. It's a deep rabbit hole which you're going to go down into. It's actually quite amazing. You will end up creating a lot of crazy stuff. You can you can do a lot of crazy things using that. Yeah.
Okay. Thank you.
Any other questions?
Okay, if no more questions, then I know Caleb keeps talking about other people's time, but we are actually taking a lot of his time. So please thank him, everyone. Caleb's taking time off from doing some very important work for the whole network. So yeah, and he's not taking any money from us, all of the payments is actually going directly to ETHKL for paying for food and stuff like that. So yeah, please thank Caleb, everybody.
Thanks, Caleb. Thanks.
Thanks, Caleb. Appreciate it.
Thanks for listening to me rambling.